Well, good day. Today we're going to be looking at the process of creating the holes in the handle hub. So what we're going to do is we'll start off by drawing the basic shape and then showing you how to put in the holes that are on that 70-degree angled surface. So as always, we're beginning a brand new drawing. We'll begin a new sketch, work in the XY plane, flip it around to the front view. As always, we're going to create a shape as a sketch and then bring it back around. So we've created the general shape. Now one of the things that I want to do is create an additional line that's going to be taller. And that line, that single line, I'm going to select it, right mouse click, and make it a center line. So we'll have a center line and the object shape itself. So the shape of the object, and again, work with critical dimensions first. So the first critical dimension is the 0.125. We know that this has got to be 70 degrees and that the overall height is a ½ inch. And the width is 1.25 diameter. So one of the cool things is that we can pick the center line, pick the vertical 0.125 line, and then we'll have a diameter value that we can put in, which is 1.25. And so what we're able to do here, just to give you an idea, again, the diameter of 1.25, and if we hit the escape key to stop, we can actually grab and move the dimensions around. And this is a good idea to do as you're cleaning up your drawing sketches, is take a second, just clean up the dimensions, because if you ever open up the sketch again, you're going to look at those dimensions and it'll be easier for you to see all the details. So we've got all the pertinent information. We now need to finish the sketch and revolve it. And again, when we pick the revolve button, it's going to revolve all the way around 360 degrees. So that works out pretty well. Okay, so now we've got a general shape. A couple of things that we want to do is we do want to construct an axis through the cylinder. And so, we can pick the bottom edge, but we ultimately want to create an axis all the way through the part. And so an axis through a cylinder, cone, or torus. There we go. And so we've got an axis now that goes through the object. So it's important to have that center line axis first before we get started. The second thing that we'll need to do is ultimately we've got to create a work plane that's on the angled surface, but we just can't pick the angled surface to throw a work plane on immediately. We have to work to that point. And it's not that it's really super difficult, it's just a couple of extra steps. So our first step that we need to do is construct a plane. We can construct a plane at an angle, and that will work. And we can actually just pick the offset plane option too, but typically plane at an angle works really well for this. So we're going to pick the center line, and we can pick, one of the cool things is that if we come over to the left hand side, and under the origin we've got basic XY, YZ, XZ planes. And so looking at your glinth, the blue and red and green, if we did X and Y, that would go around the original location. So we can actually select the XY, and I think 0, 0 is the one that we're working on here. So we've got a work plane now that goes through the center, because we pick the center line, the axis, and we've got a work plane that goes through the object. So one of the things that we're going to need to do is put a sketch plane on that work plane. And so we're going to pick sketch, and we're going to pick the work plane. So now the sketch plane is actually on the work plane. Okay. We can close the origin, and we've got a sketch plane on the work plane. So we could look at the front view, and the sketch plane being on the work plane, what I need to do is project or draw the angled line here. And so we should be able to project this angled line from the surface to that sketch plane. So if we go under Create and Project, we should be able to project the surface onto the work plane. Onto the sketch plane. And it looks like we have it. I need to, what's interesting is and so we've got a data point here and a data point here, which were projected, which is all right, because I'm going to draw a line now between the two data points, which is ultimately what my goal is to get this angled line. Once we have that angled line, our sketch is complete. So even though I picked this center angled surface and projected it, and it projected the two horizontal lines, the endpoints of those two lines make up that diagonal angled line that I'm looking for. So at this point, I'm finished with the sketch. We're not going to extrude anything. We're going to use the sketch in this next step. So that line is now going to be used to create a new construction plane. So we'll create a plane at a face and a point. I believe that's the correct one. It's either through two edges or a face and a point. We'll try the two edges first. Oh, tangent plane, that'll work. So we're going to pick a tangent plane on that angle. But we wanted to pick it at that line. Okay, so that line is what's tangent. And so that looks really good. And with that tangent plane being there, we can create a sketch on that plane. And then we can also project that line. And once we project this line to our plane, that gives us the 0, 0 location for the first hole, which in this case is the one at the very top. And so these holes happen to be a quarter 20 with a depth of 0.33. So now that we have this line, I can create a point on that line, which is at the very center, which is ultimately our goal here. And that point has now been selected at that center location. And we can finish the sketch. Now we can create a hole which is a standard drill. Let's see, yes, these are a standard drill hole. It's going to have a distance. We have to select the sketch point, which is the center. Depth of the hole is 0.33. The hole diameter is threaded. So we need to select tapped. So tapped holes means that we're going to add threads to it, and it's going to be a 1/4 20. So size is going to be 0.25. And so 1/4 20 UNC is the correct tap. Now, one of the cool things in Fusion 360 is that if I check the modeled, it will literally create accurate threads. If I don't select modeled, it's bitmapped, and I can always edit this later. So I'm going to keep it unmodeled. And so it'll create the hole. And so we've got our first hole. We then need to take and create 3 of these holes. And so we're going to do a pattern as a circle. And the object that we're going to work with is the hole, the type, and then the faces is fine. Then axis is going to be our center axis that we drew. And we need 3 around the full object. So you can see that it's going to create 1 every 120 degrees around that 360 degree object. And there we have it. It's now created 3 holes. And then the last hole is opposite the first hole we created. So the last hole is opposite on this side here. And that happens to be a vertical tangent, which is much easier to create. So we're going to flip around to the opposite side. We need to create a work plane, and it could be an offset work plane actually. So in this case we could pick offset, pick the plane would be XY, would be the XY plane. Actually, we could pick the YZ plane. So we could do the YZ plane and then offset it the distance of 0.625. Negative. Now why would we do that? Well, if we take a look, we've got a hole on this side. We want it along this outside edge of the other one, so we can offset it this direction by 0.625. So now we've got a work plane on that. We'll create a sketch on that work plane. Look at the left side view. This particular hole happens to be located, and so we'll create a point. That point is along the center line, but this one we need to dimension because that point has to be dimension 0.280 above the base of the object. We'll finish the sketch. This happens to be a hole for a counterbore, and this counterbore is a 1024 counterbore into the part. So 1024 is the threaded part, the counterbore is a 1/4 inch in diameter and a depth of 0.135. So we want to select the point and a number 10. Okay, so number 1024, so number 10 and 1024, that's the actual hole size. The counterbore is going to be 0.25 with a depth of 0.135. Now the distance is tricky, okay, because the distance it doesn't tell us, but it has to move into the center. So we need to make it at least 0.625. So the depth of the hole of 0.625, and we need to flip the direction. So there's a little arrow here for flipping direction so we can see where it's going. Now it's got to go into the center of the hole, which is exactly what is going to happen here. And so that's how we create the final one. Now the key component on that was flipping the direction, because the Z direction was not in the correct orientation. And then it will automatically create the counterbore. And as we saw last time, we create the center by bringing this in with the shaft and using the shaft as the basis for the center location of this. And once you've created one, you can copy it and create a second. That is how you can create a very cool looking hub. Have a great day.